Hi everyone. Today's lesson is lesson 1.1 and we are going to go over using the solubility rules. So by now all of you will have completed the lab where you designed how to make your solubility rules. And now we're going to talk about how to use those. Now, solubility rules always come from experimental data, and it allows us to predict whether reactions will form a precipitate or remain in solution. So this is our solubility table here, and you'll have a copy of this with you. And it gives us all the information that we need here. So, for example, if you want to put silver iodide into water, will it dissolve? What about sodium sulfide? Now, our strategy for using these, we're going to look at AgI, so silver iodide. So we're going to look here. Just thinking, I'm trying to make this bigger. Oh, so you're going to find the negative ion first here. And if we look at iodine, it's here. Now, what this tells us is that when iodine is bonded with, and silver Ag plus is right there, we have low solubility. So low solubility means that it will likely not dissolve, or just maybe a tiny amount of it is going to dissolve. So if you put silver iodide into water, will it dissolve? No. And so our AgI, you would say, is insoluble. Now we're going to do the next one, sodium sulfide. So now I'm just going to get rid of this so it's clear. All right, now if we look here, so I've got, this is going to, if it were to ionize or dissociate, it would be Na plus and sulfur 2 minus. So yeah, so I'm going to find the sulfur 2 minus here, the negative ion, and then I'm going to look and see which one is it bonded to. Now it's bonded to sodium. So if I look here, oh, look at this, alkali ion. So here's sometimes people miss this. So the alkali ions, what are the alkali ions? These are group 1. So everything in the first column of the periodic table means these ones are soluble. So make sure you look for that. It'll list it just as alkali ions, so that's group 1. So it says it's soluble here, so Na2S will be soluble. So if you were to draw pictures of each of these, silver iodide, you'd have water and then you'd have your solid sitting on the bottom, right? The sodium sulfide is going to completely dissolve, and so in here you would see Na plus, well, you wouldn't see anything actually, but you would know there was Na plus ions and sulfur 2 minus ions in there. Okay, so that's the difference between those, and that's how you use this chart. Okay. Now, we can also use it further. We can talk about when we're putting two solutions together. So we're going to work through an example here, and then we'll work through a second one. So the question is, will barium chloride, when added to sodium sulfate, stay in solution or will it precipitate out? Now, by staying in solution, what I mean by that, if I take these two solutions and I add them together, so I put them in a larger beaker together, will it still be a clear solution? Will everything stay in solution? Will everything stay dissolved? Or will we see a precipitate? And again, a precipitate is when you would see the solid collecting on the bottom, right? So that is the question here. So we're going to use our solubility chart to do that. But first, we're going to go through step by step what we need to do here. So our very first step, we're going to write a net ionic equation. No, sorry, that's not right. Oh, yeah, sorry. Okay, so this is the overall question. So if I asked you to write a net ionic equation between barium chloride and sodium sulfate, I'm going to change that to write, let's say, the complete set of equations. So the complete set of equations between barium chloride and sodium sulfate. So we have three different equations we're going to write here. So the first one, you need to predict the products and balance. So looking back here, I've got barium chloride and sodium sulfate. So barium chloride plus sodium sulfate. That's a 2. And then I want to predict the products. Now, this would be a double displacement reaction, so I know that barium is going to now bond with the sulfate ion, and sodium is going to end up with the chlorine ion, and I'm just going to balance that by putting a 2 there. And I believe, is everything all balanced? Yes, that is balanced. Okay, so I predicted the products and I balanced. Number 2, you're going to use the solubility rules to identify the states. So you have to go back to what we did here, and you're going to check each one of those. Whoops. You're going to check each one of those and see whether they're soluble or not. So we've got barium chloride first. So I'm going to look up Cl-. So I find Cl- here. When Cl- is bonded to barium, it looks like it will be soluble. So I'm going to put an AQ there. Next, I'm going to find sodium sulfate. So I'm going to look for SO4 2-, which is here. And when it's bonded with sodium, soluble. So that's aqueous. Next, barium sulfate. So now I've got the sulfate ion again, but now it's going to be with the barium. And so you're going to note that it's low solubility here. So that is not soluble. So I'm going to write solid here. And then NaCl, I've got Cl-. And again, it's going to be soluble here. And we know that anyways because that's salt, and we know that that dissolves in water. So when you predict the products and balance it and you include the states, this is called the balanced molecular equation, okay? And we would often, let's write it here. So molecular. So I would call it molecular, and I would write, sorry, this stylus sometimes is not the greatest. Okay, hold on. Okay, so I'd have an M, and then I'd have my colon there. And I would write the balanced molecular equation, predicting the products, including the states. Okay, now I have 2 more equations to do. This equation is going to be called the total ionic equation. So soluble ionic compounds dissociate into ions. So they go into solution. They dissolve into solution. So basically everything with aqueous here, I'm going to write them as ions. What is solid, this barium sulfate here, is not going to dissociate because it's not dissolving in the solution. So I'm going to go ahead and I'm going to write these with their ionic charges. So you have to have the ionic charges, otherwise they are not correct. Now you also have to balance. So you've got 2 chlorine minuses here, plus, and then 2 Na plus aqueous, plus SO4 2- aqueous. Draw my arrow. And then the barium sulfate I'm going to keep as a solid because it does not dissociate. And then I'm going to finish up with my Na plus and my Cl-. Okay, so this is called the total ionic equation. And so if I was labeling this, I would put T for total and Ti. That's a Ti there. Sorry. Ti for total ionic equation here. And so this would be the second equation that I would write. The third equation I want to write is called the net ionic equation. Now I've just copied the total ionic equation here. And what you do is you're going to cancel out spectator ions. So spectator ions are things that are going to appear on both sides. So just like if that arrow was an equal sign, if you have things on both sides of an equation, you can cancel them out. So I'm going to go ahead and do that. So I've got 2 Cl-, 2 Cl-, 2 Na plus, 2 Na plus. And then I'm left with the barium 2+, the sulfate ion, and barium sulfate. So now I'm going to copy these down, and this is going to be called the net ionic equation. So Ni, so barium 2+ plus SO4 2 minus, and again, very important to include the states here, and then barium sulfate solid. And that is going to be my final net ionic equation. So I was asked to write the complete set of equations. I've got three. I've got the molecular balanced, the total ionic, and now the net ionic equation. Now we're going to go through another example here. So this is write the set of equations for the reaction of sodium sulfide and iron 2 sulfate. Let me just see here. Oh yeah, I got that. Oops. Okay. So I'm going to start with the balanced molecular equation. So sodium sulfide is going to be Na2S plus, and now I've got iron 2 sulfate, so it's going to be FeSO4. Draw my arrow. Now, this is a double displacement reaction, so I'm going to end up with Na2SO4 plus iron sulfide, and it looks like it already is all balanced. It is. Now, before, so it's already balanced. Now I have to determine the states for this, and I do that by looking at the solubility data. So Na2S, I'm going to start with that one. So S2 minus is here. Alkali ions, which is what sodium is, soluble. So this one, aqueous. Next, I want to look at iron sulfate. So now I'm going to find the sulfate ion, and I look, and yep, it is soluble here. So aqueous. Next, I go to the sulfate ion again with Na+, and that's going to be aqueous. And then iron sulfide, if I look here, it is not one of the ones that's soluble. So this is going to be my low solubility. So that's going to be the solid there. So this is the balanced molecular equation. Now, your next step is going to be writing the total ionic equation. So what that means is you are going to take, I'm just going to switch to a different color here. Oops. You're going to take all of the ones that are aqueous, and you're going to split them apart into their ions, but you're going to keep the FeS as the solid because it does not dissociate. So we're going to go ahead and do that here. So Na2S. So I'm going to go 2 Na plus aqueous plus S2 minus aqueous plus, now I'm just going to go back, iron sulfate. So Fe2 plus aqueous plus SO4 2 minus aqueous. These get long. They get very repetitive. Now I'm going to write the other side of the arrow here. So the sodium sulfate here, that is going to break apart as well. So I'm going to have 2 Na plus aqueous plus SO4 2 minus aqueous, and then the last term was the iron sulfide, and because it's a solid, I do not write it as breaking apart because it comes out of solution. It's going to form a precipitate in this reaction. So I keep it, hold on. I have to stop doing that. Like, I find all my weird things that I say when I make these videos, and I tend to say duh a lot. I really should stop that. This is going to be our solid here, okay? So this is our total ionic equation here. Now, to find the net ionic equation, I'm just going to cancel out the spectator ion. So I'm just going to switch pens here. So things that you see on both sides of the arrow are going to be canceled out. SO4 2 minus, and whatever I'm left over with, this is going to be my net ionic equation. So now I'm just going to recopy it. So S2 minus aqueous plus Fe2 plus aqueous goes to FeS solid. Now this is the net ionic equation, so if you want to get to the root of what's happening in that big beaker that you put the two solutions in, this is what's happening, the net ionic equation. Okay. Your assignment is exercise 1, which is the solubility rules. So you've got that. The answer key is posted as well on the website, so check that out. And yeah, when we come to class next, make sure you come with all your questions. Thanks, guys.